Lesson 19 is really just wrapping everything together, all the different ways you can do proportions and solve for proportional situations. So there's zero new in this lesson, okay? So a proportion is an equality between equivalent ratios or rates. Remember that thing? Just keep it simple. Fractions, number to number. Unit rate, we've done this, right? My trick, find the item for one thing, and the one thing you want to find will be on the bottom of the fraction. So for example, if we're talking about, I don't know, kilometers per hour, and they tell you that it takes 3.2 hours to cover 117 kilometers. If you want to find how much for 1 hour, how much time, you would put your 3.2 hours on the bottom because it will solve for how much for 1 hour, and put your 17 kilometers on top. So when you divide that, so 117 divided by 3.2 hours, I'm going to get 36.56. So I'm going to get as an answer is 36.56 kilometers per 1 hour in that case. Okay, so a nice easy trick. The one item that you want to find, the one thing, you put that on the bottom. Proportionality coefficient, super easy, right? If I have a table, whatever x and y is, it's a simple formula. Y divided by x. So any one that you pick on. So let's say, even if the numbers are all mixed up, so 1, 7, 11. So let's say it's this. No matter which one you pick on, right? No matter which one you pick on. If you say simply, oh, sorry, this would be a 10, because then it wouldn't work. If you pick on any of these, so let's say the 70 divided by 7, it will give you a 10. If you pick on the 10 divided by 1, if you pick on the 110 divided by 11, proportionality coefficient will always give you a 10 in that situation. Scale factor, we really haven't talked about this one much, but it's a different way, one that you've already done. So if I have a fraction that looks like this, and I want to know if it's the exact same answer, equivalent fractions, I want to know if it's equal to or not equal to. In this case, it's not equal to, because if I can easily do mental math here and say times 10, but if I say times 10 up here, that should be a 70, right? So my scale factor, I call it my sideways method also, right? Scale factor, change factor, is based on the fact that both terms are multiplied by the same number. Also could be divided depending on which way you're traveling, okay? Product of the extremes and means, I call that my crisscross method. So we'll use a really easy one here. Maybe this, okay? So if I multiply these two, it gives you a 40. If I multiply these two, it also gives me a 40. So therefore, they're perfectly equivalent. Crisscross method. Now the next page is going to go over every single one of these, okay? So I'm going to try to just use some easy numbers so that I don't have to jump back and forth to my calculator. So for example, if I have 1 over 2 and 5 over 10, if I change those both by dividing, it's going to give me a decimal 5, and it's going to give me a decimal 5. So I can then make an easy comparison if they're equal, not equal, less than, or greater than. So, right, so they're equal to each other. Crisscross method using that same 1 times 10, 10, 2 times 5 is also 10. Another easy way that you can do some mental math checking. Obviously, if you need a calculator because they're tougher numbers, then you just do so. If I can reduce both of these to their lowest terms, and if they're the same, this one's already reduced. I can definitely do divided by 5, 1 over 2. So they're equal to each other. If you reduce both of them and they look different, well then obviously they're not the same ones. Factor of change. Can I prove that these are equal by saying, okay, multiply both the bottom and top by the same number. So times 5 times 5, it perfectly works. They're equivalent. Common denominator, because I know how much you guys love that one. Change them both to a 10. 5 doesn't change, but this would be times 5 and times 5 for the half, the 1/2 fraction. So therefore, they're equal to each other. Another one, unit rate. Now, unit rate in this case, I can't really use the same type of situation as up top. So let's say, I don't know, I'm talking about money, and I have two different scenarios. So let's say it's $12.99 for 12 roses. And my other one, let's say, is only $8.99, but they're only selling it in packs of 9 roses. To know which one is unit rate, how much per rose. Remember my trick? My $12.99, put the roses on the bottom. And my $8.99, put your roses on the bottom. Money always goes on top, but we don't often talk. We're not only talking about money all the time. So the one thing, one rose goes on the bottom. Proportionality coefficient, right? That one's pretty easy too. If you have a table and you have a bunch of, they're telling you that it's proportional, and the question is, what is the proportionality coefficient? Well, what you want to do there is you want to just kind of like, okay, whatever x and y is, you're dividing y divided by x. So a nice and easy one, right? So let's say this one's 2 and 10. So 10 divided by 2 is equal to proportionality coefficient. So it's like your magic number that you multiply or divide by to fill in your table. Cross multiply and divide. So let's say you have a problem solving situation. They talk about, if I look at the top of the page there, no, I can't really use any of those numbers. So let's say if I look at the rose question, and they're talking about $12.99, and you have 12 roses, and that's being compared to 9 roses for $8.99. If you hide one of these and you do this trick, cross multiply them, multiply those two, whoops, multiply those two, right? So this times this here, and then you divide by your leftover number. If it does not give you, if it doesn't give you this, okay, if it doesn't give you that $8.99 that's underneath there, then therefore it's not proportional. So cross multiplying and dividing is one of those things where we use a lot of that concept. So, or let's say X is your missing thing in a problem solving. So they tell you $12.99, they tell you 12 roses, they ask you how much if I want to buy only 9 roses in that situation. So you would put your X where your missing information is, and then cross multiply and divide. We already did a lot of that in our problem solving chapter. The problem solving all the way through.